Okay, so this video is for day 2 for Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about integer exponents, scientific notation, and the order of operations. I'll try to keep this video under 20 minutes. That is the goal. If I feel that I can't, what I'll do is I'll stop it partway between and we'll break it up into 2 days. Be sure to have your notebooks and your calculators in front of you so that you're ready to go. All right, second page. By the end of this lesson, you will be able to simplify expressions with integer exponents, solve problems using scientific notation, and use the rules for order of operations. Now, again, just like last class, this is all review, so we should be able to go through this relatively quickly. All right, so integers is exponents. When we're dealing with positive integers, we often use exponents. You guys are very familiar with exponents. It indicates the number of times that a factor, that should say factor, I apologize. Must have gotten a little fast-fingered there. Factor appears in a product. So if I have 5 cubed, what that means is 5 multiplied by itself 3 times. 5 times 5 times 5. No big surprise there. Okay? All right, so 0 and negative integer exponents are defined as followed. For any non-zero real number, a, and any integer m, we know that anything to the 0 power is, and please don't say 0, 1. Okay, so a to the 0 power is 1. Anything to the 0 power is 1. And a to the negative m, we know that we don't necessarily care for those negative exponents. We like them written as positive exponents. So we're going to rewrite that as 1 over a to the mth power. Okay, so there's our 0 and our negative. We'll do more work with this after. All right, so this should be very quick. Simplify 6 to the 0 power, and we get a value of 1. Okay. Negative 3.4 to the 0 power. Again, very quick. Answer is 1. Anything to the 0 power is 1. All right, so we're going to write this with a positive exponent. This should be very quick. We don't like those negative exponents, and we know that by flipping that fraction, because essentially what this is 4 to the negative 5th over 1. What we can do is we can push it to the other side of that magical fraction bar. Uh-oh. My apologies. And what this does is it allows us to rewrite this as 1 over 4 to the 5th power. And it's written with a positive exponent. Okay? Again, you guys should know this. We did this, and I drilled this into your little brains last year, so this should be pretty comfortable. Okay? So now the negative is in the denominator this time, so where are we going to move it? We're going to bump it straight up to that numerator, and we're going to have 0.82 raised to the 7th power. Now, do you have to put the 1 into the denominator? No, you don't. Can you? Absolutely. Either way is fine. Okay? All right. Again, we're writing as positive with positive exponents. We have x to the negative 3rd divided by y to the negative 8th. Now, we have that magical fraction bar there, so what we can do is we can move things around. We're going to move that x to the negative 3 down to the denominator. We're going to move that y to the negative 8th up. So what that winds up looking like, and for those of you who have forgotten how to use your calculator, we can control divide, put in my fraction template, y raised to the 8th over x raised to the 3rd. And we have our new fraction y to the 8th divided by x to the 3rd. All right, so for any non-zero numbers a and b, and any integers m and n, a to the negative m over b to the negative n is the same thing. It's equal to b to the n over a to the m. A factor can be moved to the other side of the fraction bar if the sign of the exponent is changed. So we're going to write an equivalent expression without the negatives. So again, you're looking for your negatives. If you see a negative, you're going to move it to another spot. Okay? So where are we going to put x to the 3rd? Where are we going to put y to the negative 8th? And where are we going to put z to the 10th? Well, x to the 3rd, negative 3rd, if we want to make it a positive 3rd, is going to go in the denominator. Same thing with y to the negative 8th. And that z to the negative 10th is going to come up. So let's put z to the 10th in the numerator. x to the third in the denominator, as well as y to the eighth. And we have our new expression, z to the 10th divided by x cubed, y to the 8th. All right, so here are our properties of exponents. I wrote them all out nice and pretty for you. A to the 0 power, of course, anything to the 0 power is 1. A to the negative n is equivalent to 1 over a to the n. A to the m times a to the n, when you raise a power, or I'm sorry, a to the m plus a to the n, common base, add the exponents, a raised to the m plus n. A to the m divided by a to the n. When you divide common bases, you subtract their exponents, a to the m minus n. A to the m times, or a to the m raised to the n. So when you raise a power to a power, you multiply, a to the m times n. AB raised to the m, again, remember, has to go to each piece. When you raise a power to a power, you multiply. These have exponents of 1 in there, okay? So it would be 1 times n and 1 times n, a to the m, b to the m. Same thing here. When you raise a power to a power, you multiply. So we get a to the m divided by b to the m. And to get rid of this negative exponent, what we can do is we can flip this entire fraction and make it b over a raised to the n. So take a couple of minutes to remember those. You guys have got to know your exponents, okay? So if you want to rewrite these down on flashcards, you want to make a foldable, you want to rewrite them into your notebook, please do so. Pause the video and take a few minutes. All right, so we're going to simplify this very quickly. We do have common bases. When we multiply common bases, we add the exponents. So we have y, negative 5 plus 3. And negative 5 plus 3 is negative 2, which gives us a y to the negative 2. Now, it didn't ask us to write without negative exponents. If it had, we could have very easily changed it to 1 over y squared. Okay, just a little reminder there. (48x to the 12th divided by 16x to the 4th). Okay, so we're dividing. Nothing new here. When you divide common bases, we subtract their exponent. We're also going to divide the coefficients, though. 48 divided by 16, we know that goes in 3 times. X to the 12th divided by x to the 4th, well, we're going to subtract those. Okay? So we get 3x to the 8th. Okay, I hope everybody's doing okay. All right, so t to the negative 3 raised to the 5th. When you raise a power to a power, you multiply. So we're going to have t negative 3 times 5, which gives us a value or a expression of t to the negative 15th. And again, if you wanted to write that with a negative exponent, 1 over t to the 15th power. Okay, 2s to the negative 2 raised to the 5th. Again, when you raise a power to a power, you multiply. Now, please keep in mind, you have 2 pieces to what's inside these parentheses. 2 to the first power times s to the negative 2. So you have to make sure both get raised to the 5th power. So what we wind up having here is 2. 1 times 5 gives me to the 5th times s, negative 2 times 5, which gives me negative 10. Okay. 2 to the 5th we know is 32. S to the negative 10. Or if I want to write it with positive exponents, which I normally do, keep in mind what has the negative exponent here, right? Does that 32 have a negative exponent? No, absolutely not. It has a positive exponent of 1. That 32 stays in the numerator, and the s to the 10 drops to the denominator. 32 divided by s to the 10th power. I hope the floodgates are opening and it's all coming back to you. All right, here's a big one. 45x to the negative 4th times y squared divided by 9z to the negative 8th, all raised to the negative 3rd power. So what we can do is we can start by simplifying